Hey, this is Gerry from Module Labs, and today I wanted to show you my 3D printer that I built from a kit in 2014. And this thing has been running for 11 years, and it's been really fun to maintain and update and modify this printer along the way. But I'm deciding to retire it because it's pretty slow. I got a new printer, and I just wanted to document this printer and some of the features and the journey along the way that this has kind of allowed me to enjoy. So my dad and I built this enclosure around the printer, and that keeps everything low noise and lets me vent the fumes outside. But I wanted to show a couple images from the original build manual, and that's what it looked like on the left. And then on the right side, it just shows all the connections. It uses an Arduino Mega board and this RAMPS 1.4 board as an interface to all the electronics on the printer. So I'm going to flip back to the printer, and maybe you can see some of the updates and changes, and maybe they look exactly the same, and that's fine. But it's been fun to improve on the original design. So I wanted to show a little gallery of some of the first things that I designed and printed. Up on the top left is a Chicago desk toy from my wife, who's from Chicago. Then on the bottom left, there was a community of open source modders for this printer, and this was kind of my design contribution back to the community. It is a rear mounted spool holder, which lowers the overall footprint of the whole machine. Then next to those at the top is a BL Touch proximity sensor mount that I added to the side of the printer, replacing one of the wood parts. And below that is an LED strip mounting frame that just lights up the printing area and attaches using two screws that are already on the printer. Then all the way on the right is really the start of my entrepreneurial journey, realizing that I could replace parts that are in some of the products I really love. So I worked with this company called GCW0, who designed this handheld video game emulation console, and I work with them to improve the feel of their buttons as well as offer different color options. And these were actually sold on an online store on Shapeways, where people could order these parts right to their door and replace them on the console. So it's possible to remote control the printer using a piece of open source software called OctoPrint, which runs on a Raspberry Pi computer. And here I'm just showing how you can control and move the axes back and forth. And here's the interface for OctoPrint. So you can upload part files over the internet and start and stop prints, just kind of monitor the print generally for temperature, and if something went wrong, you can look through the webcam and see what's going on, which is really nice. And you can also add some commands into the terminal to change some parameters in the firmware, all kinds of fun stuff in here. One of the most important upgrades that was made to this machine was to add auto bed leveling, and it uses this proximity sensor on the left side of the extruder that just flashed red, and this little pin sticks down and touches the surface of the print bed, and it measures this in a grid pattern. And this is done to detect any height differences across the bed because it's not perfectly flat. One of the most important things in 3D printing is getting that first layer to be printing in as high quality as it can. It helps it stick down, it helps it look good. So this was a great feature to add. And you're going to see the pin is going to get touched down on the bed surface 2 times in a grid pattern, and it's pretty slow. It takes about 15 minutes to a half an hour to heat everything up and run this auto bed leveling routine before every print. But it did really add a lot of reliability to this printer and let me use it for much longer than I probably should have. So now it's going to the second point and taking a measurement there, and these are sped up quite a bit just to show the grid pattern that it can measure. And once it's done, it's going to retract the pin out of the way. There we go. And it's going to start the print. So it's doing some nozzle priming operations just to get the plastic to start flowing through. And then it's going to draw the first perimeter of the first layer of the print. And as it's drawing that first layer, you'll notice that there's some blobs and strings and little debris coming from the print, and never really was able to get rid of those completely every time. But that's just part of this printer's quirks. And it's going to continue to draw that pattern and eventually fill it in completely. One of the most recent updates that I made to the printer was this 360 degree print cooling fan, and it uses that black fan in the front, and then that kind of ducts down into a ring that's around the nozzle of the print head, and that blows cold air down onto the print and not on the nozzle, ideally, to kind of make sure that print is cooling as quickly as it can before moving on to the next layer. So here's another angle. There is some clearance above the print, but not a lot. But this was a really cool upgrade that I kind of worked on in the last year of this printer's operation. And here's the spool holder in action that I designed, and it just pulls filament off of this roll. It pulls it up to lower the friction, and as the printer moves back and forth, it feeds more of this plastic down through the hot end and down onto the print surface. This printer's made up of plywood parts and aluminum parts, but also a good amount of 3D printed parts. And in the extruder, you can see a lot of the parts have been replaced over the years. One of the original ones is that gold skateboard ramp looking thing. That one lasted me the whole 11 years, so that's pretty awesome. So the design of this printer moves the extruder left and right, and it moves the print and the bed below it forward and backwards, and the combinations of these two movements allow you to print any shape you'd want. This printer uses a total of 5 stepper motors, one for the y-axis, one for the x-axis, 2 for the z-axis, and a smaller one for the extruder pushing the filament down through the nozzle. These digitally controlled motors rotate at 0.8 degrees per step, and by repeating those steps you can send a longer distance of movement to control the printer precisely. And then each of these motors are connected with these timing belts that are attached to bearings on the frame to keep them tight. Here's a good look at the printer's hexagon hot end that melts the plastic at the bottom, and it keeps it cooler using those cooling fins at the top, so it just melts at the bottom. These aluminum rails have slots in them that little rubber wheels with bearings inside grip onto and hold the X and Y axes in place so that they can move smoothly back and forth in the air. Instead of rails, the Z-axis, which moves the printer's hot end up and down, uses these threaded rods, and the originals were actually worn out by how much I used this, so I replaced it with this upgraded lead screw that is a lot more straight and a lot more lower resistance, lower friction, and lasts a lot longer. At the other end of this lead screw is a coupler that connects it to the stepper motor for the Z-axis, and when this rotates, it's going to lift the X-axis up 0.2 millimeters every time a layer finishes printing, and it'll keep doing that until the print's finished. And here, if we watch really close, it's about to turn just slightly. There it goes. So that moved it up the 0.2 millimeters to start the next layer. If you look really closely, you'll notice that the rod turns a little bit as the print is going, and this compensates for the flatness that was checked in the beginning with the grid pattern. When I first fired this printer up, I was kind of surprised by the musical sounds that all the motors made as it was printing, so enjoy listening to this for a little bit. And while it's fun to hear the sounds that the printer can make, after a while they do get super annoying. So building this enclosure, putting the printer inside, having a nice removable door, cut down on the print noise considerably, and it also created a place to put a bunch of LEDs to light everything up really well. Being able to see what's going on in detail was super helpful. And a few years ago I built this ducting system that it's attached to a fan that pulls air from the inside and pushes it outside. So all these tubes attached to it with these blast gates allow me to shut off ventilation to different machines that I have in the shop. One of them is running into the top of this 3D printer enclosure to pull all the print fumes out of the box as it prints. And this is really silly, but when the lights are off in the shop, there's a nice warm glow coming from the inside of the printer enclosure. Kind of reminds me of the treasure chest from Legend of Zelda, or the briefcase from Pulp Fiction, or a little Bob Ross cabin in the hills with the warm light coming through the windows. As I give this printer a fond farewell, I never could have imagined in 2014 building this how much of an impact it would make on my life and career. It got me more interested in my hands-on technical skills, upgrading the printer, but maybe more importantly, it got me super interested in 3D design, CAD, and industrial design, which I ended up pursuing as a master's degree and work in that field today. And also the ability to just come home and dream up anything I'd want to create with the printer unlocked this entrepreneurial journey for me as well, with Module Labs, printing products from home and shipping them all over the world. So next up, the printer is going to become a nice piece of shop decoration for me, but I'm going to keep the enclosure and put a new watch cleaning machine inside, and that's what's next. So thank you so much for watching, and I really appreciate all the support.